Hey everyone, and welcome back. When we talk about large language models, or LLMs, like the ones powering AI chatbots and generative tools, it might seem like they're all similar. But there are actually several different types of architectures, each built a bit differently for different purposes. This chart gives us a great overview of 6 main types of large language models. Let's walk through them quickly. First, we have autoregressive models. These are perhaps the most common type you hear about for text generation. Their core idea is simple: they predict the next word or token in a sequence based on all the words that came before it. They build text sequentially. GPT-3 is a classic example of this type. Their workflow involves steps like tokenizing input, embedding it, adding positional information, passing it through transformers with self-attention, and finally predicting that next token. Next are transformer-based models. The transformer architecture is actually the backbone of most modern LLMs, including the autoregressive ones. What defines them is their heavy reliance on self-attention mechanisms, which are excellent at capturing long-range dependencies in text, understanding how words far apart in a sentence or document relate to each other. Roberta is shown as an example here, often used in tasks like understanding text rather than just generating it word by word like purely autoregressive models. Third, we have encoder-decoder models. These models are built in 2 parts: an encoder that processes the input text and converts it into a numerical representation, a vector, and a decoder that takes that representation and generates the output text. They're particularly strong for tasks where you need to transform one sequence into another, like translation, encoding a sentence in one language, decoding it in another, summarization, or question answering. MT is given as an example. Fourth are pre-trained and fine-tuned models. This describes a common training strategy rather than a specific architecture type, though it often applies to transformer models. The idea is to first pre-train a large model on a massive dataset to learn general language patterns, and then fine-tune it on a smaller, specific dataset for a particular task, like sentiment analysis or classification. Electra is an example shown here, illustrating the flow from gathering data, training a base model, and then updating layers for a specific task. Fifth, we have multilingual models. These are designed specifically to work with multiple languages. They are trained on data from various languages, often using shared vocabularies and special techniques to enable cross-lingual tasks like translating between languages or performing analysis on text regardless of its origin language. XLM is shown as an example, highlighting how they use transformer layers adapted for multilingual input. Finally, hybrid models. As the name suggests, these models combine different architectures or learning methods. This could involve mixing elements of RNNs, transformers, or other techniques to balance different strengths, like achieving robustness, fluency, or specific structural properties in the output. Unome is listed as an example here, representing models that might merge or stack outputs from different internal components to handle complex tasks. So, as you can see, while the transformer architecture is foundational for many, the way they are structured and trained leads to different types of LLMs, each with strengths suited for different applications, from generating text one word at a time to translating languages or understanding information across different contexts. Which type of LLM do you find most interesting? Let me know in the comments below. If this overview of LLM types was helpful, please give the video a thumbs up and subscribe for more AI tech breakdowns. Thanks for watching, and I'll see you